Hello everyone. Yesterday we saw the basic definitions of analytic functions, necessary and sufficient condition to check whether the function is analytic in both Cartesian and polar form, and what is Cauchy Riemann equation. And then we saw an example how to check whether the given function is analytic. So now today we need to see f of z equal to e power z is analytic or not. Then we need to find its derivative. So take f of z as e per z and rewrite z as x plus iy. Z is x plus iy. Then e per z becomes e per z. You can rewrite it as e power x plus iy. Then that can be rewritten as e power x into e power iy. And this e power iy can be rewritten as e power I theta. So we know already how to rewrite e power I theta. So e power I theta can be rewritten as cos theta plus I sin theta. So in this way I can rewrite this e power iy as cos y plus I sin y. So now we got f of z in terms of x and y. Now separate the real and imaginary part. Real part we should take it as u. Imaginary part take it as v. Then find the first order partial derivatives of u with respect to x, u with respect to y, v with respect to x and v with respect to y. Then after finding this, all the first order partial derivatives exist and they are continuous. Then we need to check whether it satisfies CR equation. We need to check whether ux equal to vy. Yes, ux is equal to vy. Then we need to check whether uy equal to minus vx. Yes, uy equal to minus vx. So CR equations got satisfied. So I can say that the function is analytic. So after concluding it is analytic function, next I need to find what is the derivative of this function. How to find the derivative of this function? I need to use this result f dash of z is equal to ux plus ivx. Ux plus ivx. Then I need to substitute what is ux, u suffix x, that is dou u by dou x, which is e power x cos y. Then I need to substitute what is vx. Vx is derivative of v with respect to x, partial derivative of v with respect to x, which is e power x sin y. Then I can take e power x common from this. So it becomes cos y plus I sin y. Then this cos y plus I sin y I can rewritten as e power iy. So I'll get e power x into e power iy. So now I can combine these two exponential term and I can rewrite it as e power x plus iy. So x plus iy I can rewrite it as e power z. So derivative of f of z equal to e power z is same e power z, and we got the same answer. So like this we can find what is the derivative of the given function f of z. Similarly, the next example, we need to find f of z equal to cos z analytic. So we need to replace z with x plus iy. Then we need to expand this. This is of the form cos a plus b. So cos of a plus b is cos a cos b minus sin a sin b. Then we are having cos of iy, and we need to know this, which is called as the relation between circular function and hyperbolic function. Hyperbolic function. So cos of ix can be written as cos hx and sin of ix can be written as I times sin hx. So I can rewrite this cos iy as cos hy, and I can rewrite sin iy as I times sin hy. I is written here and sin hy. So now cos x cos hy is the real term and minus sin x sin hy is the imaginary term. So you can identify what is u and v. Then we need to find what is the derivative of partial derivative of u with respect to x, partial derivative of u with respect to y, then v with respect to x, v with respect to y. Then after finding this, we need to check whether it satisfies CR equation. Yes, it is satisfying the CR equation. So partial derivatives exist and they are continuous and it satisfies CR equation. So I can say that the function is analytic. Then after concluding it is analytic, I need to find what is the derivative in the usual manner, taking ux z f dash of z equal to ux plus ivx. So substitute what is u suffix x, that is partial derivative of u with respect to x. Then substitute partial derivative of v with respect to x. Then we need to reverse, that is hyperbolic function is here. I need to rewrite it in terms of circular function. So cos hy I can rewrite it as cos hx I can rewrite as cos of ix. Cos of ix. Then sin hx is equal to sin hx is equal to 1 by I times sin of ix. Okay. So this I and this I will get cancelled. So minus of minus it will become no, this minus will come in the middle. So minus sin x cos iy minus cos x sin iy. So I can take minus common, and this is of the form sin a cos b plus cos a sin b. So sin a cos b plus cos a sin b is sin of a plus b. So minus of sin of x plus iy I'll get. X plus iy is z, so I'm getting minus sin z. So the derivative of cos z is minus sin z. So this way we can find what is the derivative of the analytic function. Likewise, you can practice the other example. The next example which is given there is sin hz, and that we need to rewrite and separate the real and imaginary part. Then after separating real and imaginary part, we can prove it is analytic, and then we can find what is the derivative. And there are other problems listed here for you to try.